Okay, first let's determine the velocity function. We write velocity function, velocity v of t, and this equals the antiderivative of the acceleration function. And so we write down this integral by replacing a of t, which is 2 sine t plus 1 dt. We integrate this as two parts, that is integral of 2 sine t dt plus integral of 1 dt. We can factor this 2 and then write this as integral of sine t dt plus this one is integral of 1 dt. Now we know that using the standard integration formula, the antiderivative of sine t is negative cosine t. So we write 2 times of negative cosine t plus the integral of 1 dt is t, and then we put the constant of integration plus c. So this basically is the velocity function, but we should determine the constant of integration c using the initial condition, that is v of 0 equals 0. So let's determine that. So I'm going to plug in t equals 0 implies v of 0 is given as 0. So therefore, if we plug in t equal to 0 here, we will have v of 0, and this equals, this is negative 2 times of cosine 0 plus replace t by 0 plus the constant of integration c. V of 0 is given as 0, so replace this v of 0 by 0, and this equals negative 2 times cosine 0 is 1, so it is negative 2 times 1 plus this one is constant c. Now here we can solve for c by adding 2 to both sides, so we get c equals positive 2. And thus we have determined the constant of integration c, which means we can put this into the velocity function, that is this equation. So we now write the velocity function v of t, this equals negative 2 cosine t plus t plus replace c by 2, this is 2. And so this is the velocity function v of t. Now we determine the position function. So we write position function s of t. This basically is the antiderivative of the velocity function v of t. So let's determine this integral. Replace v of t by the velocity function, that is negative 2 cosine t plus t plus 2 dt. We can write this as two separate integrals. So first one will be negative 2 cosine t dt, and I can also factor out the negative 2 and then rewrite this as negative 2 times of integral of cosine t dt. Then the next integral is t dt. So integral of t dt plus the next integral is 2 times dt, which I factor 2 and then write down this as integral of 1 dt. And so this equals negative 2 times. The antiderivative of cosine t using the standard integration formula is sine t plus the antiderivative of t using the power rule of integral, that is x raised to the power of n dx. This equals x raised to the power of n plus 1 over n plus 1. So here the power of t is 1. This means this equals t raised to the power of 1 plus 1, which is 2 divided by the same number 2. So the antiderivative of t is t squared by 2 plus 2 times the antiderivative of 1 is t. So it is 2t. And then we also put the integration constant c. So this one is the position function s of t, but we have to determine the constant of integration c using the initial value. The initial value given here is s of 0 equals 3. So let's use that. That is s of 0 equals 3, which means when t equals 0, s of 0 is 3. So let's plug in t equal to 0 into this position function, which gives s of 0 equals negative 2 times of sine 0 plus 0 squared by 2 plus 2 times 0 plus the constant of integral c. Now replace s of 0 by 3, and so the left side is 3 equals sine 0 is 0, so this one is 0. This factor or this term is also 0. Here also it is 0. And finally we get c on the right side. So this gives the value of c equals 3. We determine the constant of integral for the position function c equals 3. So we now write the complete position function by replacing c by 3. So therefore s of t, that is the position function, equals negative 2 sine t plus t squared by 2 plus 2t plus replace the c by 3. And so this is the position function s of t. We now determine the average value of s of t from t equals 2 seconds to t equals 5 seconds. So we write average value of s of t. This equals, we put 1 over b minus c, that is 5 minus 2, and then integral of s of t dt, and we also put the limits of this integral. Since t equals 2 is the lower limit and t equal to 5 is the upper limit. So let's find the definite integral. And so this equals 1 by 3, the integral from 2 to 5. Replace s of t by the position function which we have already determined. So I'm going to replace s of t by negative 2 sine t plus t squared by 2 plus 2t plus 3. Then we put this dt. So we have to find the integral of each of the terms inside this integral. You can split this as two separate integrals. I put this multiplier 1 by 3 in front, and then we put this definite integral for each of the terms. That is, for the first term, it is negative 2 sine t definite integral. So we can write this as I factor the negative 2, and then write this as 2 to 5 integral of sine t dt plus t squared by 2. It is, I can factor out the 1 by 2 and then find the antiderivative from 2 to 5 t squared. Similarly for 2t, I can factor out the 2 and then put this as 2 to 5 t square. This one is t dt, and finally this one is 3 antiderivative 2 to 5 1 dt. Let's evaluate each of these different integrals. And so this equals 1 by 3 times negative 2. Antiderivative of sine t is basically negative cosine t, and this must be evaluated from 2 to 5. Plus we then have 1 by 2 times, here we have dt. In fact, the integral of t square is t cube divided by 3 when we use the power rule of integral, and this must be evaluated from 2 to 5. Likewise, here we have 2 times the integral of t is t squared divided by 2. This must be evaluated from 2 to 5, plus 3 times the integral of 1 is t. This also evaluate from 2 to 5. We close this bracket for the multiplier 1 by 3. And so this equals 1 by 3 times, we have a negative 2 times negative, which is a positive cosine t. And then we replace the upper limit and the minus the lower limit. So this will be 2 times of cosine 5 minus cosine 0. I'm sorry, cosine 2 plus we can multiply these two numbers in the denominator, and so this becomes 1 by 6. We then replace the upper limit 5, which is 5 cube. 5 cube is 125 minus, then replacing the lower limit 2, it will become 2 cube, which is 8. And then we see that these two numbers gets cancelled. Here we have t squared. So if we apply the upper limit 5, this will become 25 minus 2 square is 4, plus finally we have 3 times of uh, apply the upper limit 5 minus the lower limit, which is 2. Let's simplify this. So this gives 1/3 times 2 times of cosine 5 minus cosine 2 plus this one is 1 6. 125 minus 8 is 117, plus 25 minus 4 is 21, plus 5 minus 2 is 3. 3 times 3 is 9. And so we can put this in simple form. That is, this one is 1/3 times 2 times of cosine 5 minus cosine 2, plus this one is 117 divided by 6, plus 21 plus 9 is 30. Or otherwise, distributing this 1 by 3 into the terms inside the bracket, we get 2/3 of cosine 5 minus cosine 2 plus 117 divided by 3 times 6 is 18, plus 1/3 of 30 is 10. So this is the expression of the value of the average value of the position function from t equals 2 to 5 seconds. We can find out the numerical equivalent by plugging this expression into the calculator. And when we do that, we get 16.50 feet. And this is rounded to 2 decimal places. So this is the average value of the position function.